Good day. It's Thursday, May the 27th. I'm Martin Gagel with Market Radius Research. Today we're joined by Peter Londa, CEO of Tantalus Systems. So now we are going to enter the Q&A part of the presentation, the deep dive, I call it. You talked about your, very much the opportunity here. And then you talked about you've got some edge computing devices and software and services. What exactly do you do? It sounds like you're a communications mechanism, so utilities know kind of what's going on in their grid, or what are what are the products you sell, or the software platforms, or that's something a little more concrete we can kind of wrap our heads around?
We build and deploy devices to proliferate out and build a communications network for utilities. That's the heritage of our business that dates back 30 years. The communications network uses, as you can see down here, we call it our smart grid network, a variety of different tools: RF, radio frequency technology, fiber connectivity, cellular connectivity. But what you're looking here is a collection of devices. I'm circling with my mouse. These are physical devices that we've designed, own the intellectual property, and actually build that deploys a proprietary communications network, meaning utilities aren't relying on Verizon, AT&T in the United States, cellular networks. They have their own utility proprietary communications network to access data. So in building out the communications network, towers, repeaters, collectors, we then also build our intellectual property. We have third-party manufacturing, so we're CapEx light, but we build a communications module, which I'm circling here with my mouse. It's a circuit board, this green board, that looks very much like the guts of your iPhone. I wouldn't recommend you breaking your iPhone in half, but if you did, you'd find a device that looks like this. This is a device that has an ASIC chip, custom ASIC chip, that can support parallel processing of data. We have RAM and flash memory embedded on this device with backup power, and then a software configurable radio. What that allows us to do is that this thing gets integrated under the glass of a meter. And what you're looking at here, I'm circling, is an electric meter. We don't build meters, but if you were to disassemble the meter on the side of your home, assuming that your utility was one of our customers, you'd find our intelligent Linux-based edge computing device underneath the glass of that meter.
Is that basically like a modem?
No, it's substantially more than that, Martin. This is a mini computer,
okay,
that can not only analyze data, but with a Linux-based operating system on it, can compute and take action. And then with a radio on it, communicate data over our network.
So if something happens at the endpoint where it's at, and let's say there's no radio communication, if it's programmed to have whatever smarts, if the load goes up or down or whatever, it can say, oh, we better change something here. So it has some smarts to respond to the environment to change some of the parameters.
Correct. And when it does that, it then reports either what's happened or what action it's taken up through the communications network into our software, our own intellectual property, that is deployed and used at the command center of a utility to say, I'm a meter at Martin's home. There's a power quality issue. There's an outage. I've got an increased amount of consumption. That provides visualization to the utility to determine, is there a problem at your home? Are you stealing power? Is there a problem at the meter? Is there a problem with some asset, a pole top transformer or the power line connecting to that meter? And so what we're doing, Martin, is we're giving visibility to the utility on what actually is happening at the very edge of their network, meaning the meters themselves, based on the information from meters deployed in the field. the utility can then determine where they've got inefficiencies, where they have an outage, where that outage actually started, as an example, where they potentially have theft or people who are not paying their bills. And as a result, then change their operations or change their tactics to ultimately improve their own sustainability.
So I'm going to use some bad analogies here. So you deploy these things at the edge of the network or the utility network. Are you sort of like the iPhone of the network where they deploy you, or are you more of like the AT&T or the Verizon where you build their entire communications network as well as deploy your hardware at the edges of it?
So we're both.
That made sense.
We're both.
Okay, so you build out these communication networks using some of your own proprietary hardware and software, as well as using third-party repeaters or whatever other communications devices to build out this network. And then you've got the software cloud, presuming backbone, where you collect and manage and sort of filter through all the data that's been collected by the network you built.
So we're the Verizon in that we have our own communications equipment.
Yep.
Okay. We're the iPhone, where we have our own device that both captures and analyzes and reports data. And we're the Microsoft with the tools that help the utility understand what actually is happening and have visualization and command and control of their network.
All right. So when you start a relationship with a utility, I guess they're I'm guessing, one of two ways it could start off. They put up an RFP and say, hey, we need to build a new utility communications platform. Here are the specs, throw in your bids. Or maybe, hey, we've got this old one that needs a refresh, or we need someone else to kind of manage it. And is that kind of the two ways that you get into helping manage these communication systems?
Not exactly.
All right.
So what we'll see is at a very high level, a utility, let me backtrack. When you and I were growing up, we're similar vintage. The utility had a meter reader that would show up at the side of our parents' homes with a pen and paper in hand and physically look at the meter, take readings off of the meter, write them down on a piece of paper, and then walk to the next house. That's how meter reading was done. And it was typically done once a month, and it was geared solely to determine how much electricity was consumed at the home for purposes of generating a bill. Does that make sense?
Yep.
Okay. Over the years, mind you, there are still some utilities in the United States, Canada, and the Caribbean, not to mention the rest of the world, that still do it that way today. They still physically send a person to the side of someone's home to determine a reading once a month. Archaic in today's world, if you think about it.
Sure.
Okay. So in some circumstances, we have utilities that are trying to migrate from the old-fashioned meter reading, person to person, house to house, 1 month, one time a month analysis to an automated system that, with communications capability and with computing capability and software, can pull consumption data, not once a month from a meter reader, but every 5 minutes, every 15 minutes, automatically, and fill that into a database and a set of software tools to not only understand how much electricity each home, each building is consuming by minute, by hour, by day, but also fluctuations on that consumption pattern for planning purposes. So example, if the weather, middle of August, I live in the New York metropolitan area, it's 95 degrees and 100% humidity, my air conditioning is probably running 80 to 90% of the 24 hours during that period of time. The utility can start to capture that data. They can track that data. They can store that data. They can compare it to weather patterns to predict what will the power consumption be relative to weather patterns, as an example. That's the automation that we can provide them. So that's one way that we get involved with the utility. The utility has the epiphany that it's time to stop relying on meter readers once a month and start automating the process of collecting and capturing data as it relates to consumption for billing, but also most importantly, power quality, power reliability. That's one way we get engaged. The second way we get engaged is beyond the individual meter reader. From the days when we grew up, there are some utilities that started to migrate to what's called a drive-by meter reading system. These were legacy devices deployed in the field that relied on paging technology. And it was a device in the meter that would blurt out a signal. And instead of having someone go house to house, block by block, they put receivers into pickup trucks or other vehicles, and they would drive the vehicles down the street and collect those meter reads once a month. Similarly, we've got a unique ability with our technology to get rid of the truck so they don't have to longer drive. And through our communications network, our proprietary technology, Martin, can start to read those devices at a minimum daily, if not hourly. That's how we get engaged with the utility. And so the first thing when a utility says, okay, Tantalus, it's time for us to get into the modern century, we need to understand consumption for billing. We need to understand consumption for planning and investment. We need to understand power quality metrics, current and voltage, time to automate and use technology, right? We engage, and the first thing that we deploy is a communications network that covers all of the meters in their footprint so that we know we can access data from every single meter, every single home that generates revenue for the utility. As the communications network is deployed, we then help the utilities upgrade from legacy meters that didn't provide any data to an iPhone, in your example, a device that has computing power. It's an IP addressable device that we can both speak to and that can speak back through the communications network to the utility. Does that make sense?
Yeah, and so because there are smart meters, but the technology that you have isn't something that comes standard in a smart meter. That's sort of you're adding some smarts to the smart meter.
The definition of a smart meter is a meter plus a computing platform.
Okay.
Or the computing platform.
Gotcha.
Okay.
All right. And so when you have a utility as a client, does that necessarily mean you've got their whole network that you've sort of built and are managed, or are some of them sort of bought the full meal deal, or some of them are just, hey, we've got someone else running, or maybe we're doing our own communications network, but we're going to use your sorry, what do we call the little smartphone in the meter? How do we refer to that?
We refer to this as our communications module.
All right. So, okay. And some places just say, okay, we'll buy a Tantalus communications module and put that out there, and they have other systems to run it. So you just sort of get a one-time hardware fee, or is it always sort of an all-encompassing system?
When utilities select us, they're buying an entire system.
All
they're buying the devices and our technology know-how and expertise on building out the communications network, these blue dotted lines.
Yeah.
They're purchasing the communications module from us.
Yeah.
And they're purchasing licenses to our software. And so our revenue mix is a combination of hardware, software, and professional services.
Gotcha.
They can't just buy the communications network today. They can't just buy the communications module and have that on a third-party network. They can't just buy the software solution standalone. It's not a Chinese menu. They're buying an entire system.
Gotcha. All right. So, and then I'd
say, Martin, just to make sure the point wasn't lost in my presentation, when a utility buys our system, it's expected that this system is in the ground and providing value to the utility for anywhere from 12 to 15 years.
Yeah.
So it gives us a great opportunity from a business strategy perspective. Land the utility, get them deploying this system, the communications, the edge computing for smart metering, and the software and services. And then over that 15-year period, we're generating recurring and repeatable revenue through software licenses, ongoing professional services. And then as we diversify our product portfolio through mergers and acquisitions or our own R&D initiatives, we're able to then add more features, more functionality that all leverage the same communications network and the same computing capabilities. So we help the utility expand their return on investment over 15 years.
And I'm guessing that when you do the initial sale, that is heavily more hardware weighted than the rest of it. And then in the subsequent years, a new house gets built, so they got to buy a new communications module, and things break down and they need replacement. But more, the biggest revenue is up front, and then it transitions more to software heavy, presumably higher margin, less hardware business through the remainder of those 15 years. Is that a good assumption?
Correct. So when the utility is first deploying our system, on average, it varies, but somewhere between $110 to $125 is paid per meter. And then over the life of that deployment, 12 to 15 years, today we're generating roughly $4 per meter per year once it's deployed in the field.
Okay.
And I see a question that came across on gross and EBITDA margins. That's what ultimately drives a blended gross margin. The gross margins on our hardware, because it's very differentiated and very comprehensive, you'll see through our MD&A and our financial reports, our gross margin on hardware is in the mid to upper 30th percentile. Our gross margin on the software component of our revenue is, as you would expect, in the 90s percentile. And on the professional services level, we're typically in the mid 50s from a percentage perspective for gross margin. So that all blends hardware, software, services in the aggregate to, in 2020, a 49% gross margin. On the EBITDA side, since we're still small, we're not yet at operating leverage. We're generating about 7 to 8% EBITDA contribution margin. That was what we did in 2020 on a full calendar year. So we still have room to grow in terms of our EBITDA contributions as we continue to scale. Our target is in excess of 15% EBITDA margins as we get to broader scale from a financial perspective. I didn't mean to cut you off, Martin, but I know we're starting to run to the top of the hour, and I saw that question come across, so I wanted to make sure we addressed it.
Okay, no, that's great. Yeah. So you have 190 utilities ish as customers. They're tiny utilities in the US or in North America, and then they're really big ones. What's your average size utility? Would you do a New York, or is that more sort of small medium markets you do, and kind of what market share do you have, however one would calculate that?
Yeah, sure. So we didn't cover that in the presentation, so thanks for the question. Within the United States, a little bit different in Canada and other places, similar, but a little bit different. There are investor-owned utilities, Con Edison in the New York metropolitan area, one that's got a tough history over the last few years in San Francisco, Pacific Gas and Electric. These are utilities that support millions of homes in the largest metropolitan areas of the United States, and they're publicly traded on the New York Stock Exchange. Those are referred to as investor-owned utilities. There are roughly 180-ish of those. My number might be off a little bit there, but it's close.
Yeah.
There are then roughly 3,000 what are called municipal and electric cooperative utilities deployed across the United States. These are the township of Chatham in Ontario, as an example, the city of Chattanooga in Tennessee, the city of Riverside in California, which neighbors Anaheim. These are cities that actually own their own distribution grids. They're not in the business of generation, and they're not in the business of transmission. They're solely in the business of distributing electricity to the residents of their city. That's the type of utility we go after. Those utilities range in size from as small as 1,000 meters, very small rural communities, to as large as 500,000 meters. There are a handful that are a little bit bigger than that. The vast majority of munis and co-ops are smaller than 100,000 meters per utility. It scales down substantially lower than that. And so that's the market segment that we focus on. And again, the complexities and the issues associated with the New York metropolitan area versus the Appalachian Mountains of Tennessee are fundamentally different. And what works in Manhattan ain't going to work in the Colorado Rockies or the Appalachian Mountains in Tennessee. And so we're purpose-built. We're building solutions to fit that market segment, the municipal and rural cooperative utilities. There are roughly 3,000 utilities. We support 190. My back of the envelope calculation, about 1,000 utilities have automated to competing solutions and ours. So we probably have about a 20% market share. There are ballpark about 1,000 utilities that have invested in legacy AMR systems that are in the process of starting to think through what's next. And there's still a good chunk of utilities that still haven't done anything, that do it the good old fashioned way of meter reading with a person. And so we're chasing after a fairly large and robust market opportunity. They're smaller utilities by definition, but they are community owned and supporting a segment of the market that it's a little bit harder for the larger players to scale down to. We scale very well to those. That's where we focus today. There are exceptions to that rule, obviously, with support to the investor-owned utilities, but our purpose is really to help these smaller utilities in smaller towns, not smaller utilities, but smaller towns and rural communities.
And at 100 or 125 bucks per endpoint, what is the average size of one of these of your kind of target market? Is that like $1 million contract or?
Yeah, so that's not information that we make publicly available because I don't need to educate our competitors too much. But yeah, order of magnitude. The typical opportunity for us is in the couple $1 million range. There are some circumstances that fall below that. There are some circumstances that are well above that.
All right, and I'm directly addressing a question here. Now that with the product and we sort of understand the market, and there are obviously competitors in that, why is Tantalus positioned to capture this huge market opportunities and the critical needs to upgrade their grid, and what kind of investments will happen over the next 5 years? There's a lot there where there's obviously a lot of money going into the utilities, and there's a drive towards that. But I guess, like, why you? Why not your? What do you do better than your competitors? Yeah.
We could spend an hour on that question, so thank you for it. I'd sum it up in one word: purpose. What we do is design technology that meets the specific needs of the market segment we target. And we do that in an exceptionally efficient and economical manner. And unique to us versus the largest players in this market segment, that some of which are on that comparable slide, and I'm sure, Martin, we can make these slides available to those who are interested, or you can find it on our website under our investment landing page. We have a unique ability of capturing data in a very granular fashion. And because of the way we capture data with technology, we as a result are able to provide that much more visibility and in-depth understanding of what's actually happening on the distribution grid. And we make that presentable through our software and data analytics. The connectivity is very important. The edge computing is very important. What makes us different is the ability on how we capture that data, how we deliver it with low latency, meaning fast, high capacity, meaning getting data through the system quickly, and ultimately populating into a set of tools that fundamentally changes the way the utility operates every single day. And we're doing that, as I'd mentioned, with a very specific purpose. It's to improve the efficiency, the reliability, and the sustainability of that utility. I think that's why we are very successful in adding on average 20 new utilities a year. It's why our compounded annual growth rate of our user community has been in excess or at 20% for 8 consecutive years. I think the proof's in the pudding in terms of the focus that we have and the purpose of our company.
You have, like, your intellectual property, do you have patents, or is it more sort of engineering expertise, and so forth? Okay,
yeah,
you got
both. We have a set of things that we've patented. We've got a substantial amount of technology know-how and in-house knowledge that, the pros and cons of patenting. As a private company, on the one hand, you could think of it as protection. On the other hand, you're effectively communicating to the world how you do things. And unless you have a war chest and an IP attorney on staff and at your disposal, enforcing those patents can be incredibly expensive. So where we think there's clear opportunity from a patent perspective, we've pursued that. But a lot of what we do is our own in-house know-how.
All right. We have two questions here on your M&A. And without giving away too much, what types of technologies or services would be complementary to your existing opportunities? And I think both questions kind of cover the same type of thing. What would they be? New software? And I'm talking here now. Would those be more software analytics type stuff for new types of hardware to capture or control different types of data? Or what kinds of things would help add value to you and, of course, your customers ultimately?
Yeah, so the answer is both. Our goal is, and I use the expression, and we're using this quite a bit, land and expand. We're landing utilities by getting devices deployed in the field. So as we think about an expansion of our capabilities, we're very effective today at and to the meter. So from the substation down to the meter, where we are quickly looking at and thinking to expand from a device perspective is inside the home. It's how do we help utilities understand where solar panels, battery walls, and EVs have been deployed? And then most importantly, how do they, through bilateral relationship with their end user, their customer, access those devices and resources as a potential source of power when Mother Nature strikes, or when they've got an imbalance between the supply curve, power, and the demand curve, consumption. So we're very aggressively looking at where we can find strategic benefit of incremental devices, all of which would connect through our communications network. The second area of focus, and I'm not prioritizing one or the other, but just following your comments, is then on the software and analytics side. In particular, it's really on the analytics side. We're capturing 30 billion data points a year today across 190 utilities. So what we're focusing on is how do we identify organizations that have built some really interesting algorithms for analytics based on the data that our devices capture. And based on that algorithm, how do we then convert that into a software tool or data analytics tool to help the utility solve more problems? So as we think about the growth, the devices are important to us. They access the data that is needed for utilities to make better decisions. And then similarly, where we're investing a lot of our own R&D dollars is then not only how do we access that data, but what do we do with it? And that's on the software and analytics side. And so those are really the two primary areas of focus today from an M&A perspective.
Is there a big data angle on this where you're able to access your 190 utility customers and sort of learn behavior, what happens here, and sort of apply it to here or to new customers, where the more data you get, the more it kind of benefits your whole network?
Absolutely. So I like to say if we do our jobs well, right, we're a data analytics and data analysis organization. No different than the way the internet has changed so many industries through accessing data. The utility industry, in our opinion, is no different. They're just behind. And so as we think about it, the computer only has as much value as the software only has as much value as the hardware. None of it has value unless it can communicate. So from our circumstances, in terms of really helping the utility, we need both. We need all three. We need the communications capability. We need the hardware. That's what captures the data. We need the software. What do we do with that data? And so there is very much, especially with our recent press release in March, introducing our first true AI-based data analytics tool that will help utilities pinpoint and proactively manage transformers, pole top transformers, and what we refer to as momentary outages in the utility industry. It's all tied to data and the extrapolation of data from devices, and then the triangulation and analysis of that data. So this is a massive data play for sure.
All right. There's a question here, which is good for any sort of growth company, where what is management's focus on the coming years? What's your balance between managing growth and profitability? Like, you could throw everything plus more at sort of driving growth, or what kind of balance are you trying to achieve? Because like everyone, I think at this point is investing in a growth company, and they're not looking for dividends here at this point. So what is the balance, and what's sort of the approach you're looking before you try to sort of get mature and try to maximize margins?
Yeah, so what I'd say is that's where I'd referenced we've got as a management team now 4 consecutive years of delivering positive EBITDA. Within the financials, right, it's single digit EBITDA contributions, 6%, 7%, 8%, but it's better than negative. What we are striving to do as a management team is to make prudent decisions in a disciplined manner that will provide our shareholders with sustainable and profitable growth. There may be a few opportunities where it's worthwhile to invest cash in the near term to accelerate growth in the long term. But we come from a heritage, certainly since I've joined this company, where we have not had the benefit and the luxury of a lot of cash on our balance sheet. So the decision making that we've had to do has been very much disciplined, right? Where if we make some mistakes, we've got a balance sheet problem. As we've gone public, our balance sheet is as strong as it's been in our company's history. As we continue to potentially access capital, we hope that trend continues. But what we are striving to do is absolutely drive growth, but do it in a disciplined and responsible manner where we can continue to deliver positive EBITDA. What I'd say is this is not, and we're not building a business, nor do I think our existing shareholders look at it this way of the company quadruples in a 1 or 2 year period of time. Utilities move slowly, but they move deliberately. And when they move, it's massive dollars. And if you look at there's some research, Martin, in the world that we're making available, to decarbonize the power grid in the United States alone is estimated to be a $20 trillion investment required. Our goal is to put ourselves in the best position possible to grow the business, but do it in a responsible manner in conjunction with those investments that are forthcoming.
So we shouldn't be expecting big fat EBITDA margins. You're not here to milk the sort of the business, the opportunity. You're trying to have a responsible balance where you're self-sustaining, but you're also growing as much as you can with your current economics.
Yeah, absolutely. Our goal is to access more capital to support growth initiatives, not to fund operating losses. And I think that's a big difference in the way we look at the world and how we're approaching this business and how we're approaching the opportunity.
All right. Another question here that I don't think we've quite addressed. Utilities have a lot of issues going on, and sort of the key out of this is, what are the executives of utilities indicating to you that about the issues they are currently facing? And they have a lot of issues they're facing. What are their top things? Is it like going from a one-way power system to a two-way where a client is a supplier and trying to sort all that out?
Yeah, and I'm sorry to distract with slides, but I think let me try to explain a few ways of answering that question. So first and foremost, there was a terrific analysis and survey completed earlier this year by the consulting firm Anderson Consulting, and it canvassed utility executives across the United States in terms of the direction of the utility industry and the need for investments. To that end, the survey concluded that 90% of the executives in the utility industry that responded all acknowledged that more investment was required over the next 5 to 10 years to automate the grid and to migrate it from the legacy design that Thomas Edison came up with over 100 years ago, of a legacy one-way power flow from a central source of generation down to an endpoint, right, to turn it into an omnidirectional, multi-directional grid. And the reason for that is I don't think anybody's going to stop the emergence of electric vehicles at this point. And while there's excitement, obviously, and opportunity with electric vehicles, there's a cascading impact. Utilities see it, I think, in my opinion, in spades. The transformers that are deployed, the substations that are in operation, the circuits and the feeder lines were not designed to handle the incremental demand to power transportation. And as we think about reducing gas vehicles and migrating that to electric power vehicles, the electric utility industry has got to be prepared to support that transition in fuel. That's not the way the grid's built today. They've got to also do that with a mandate here in the US to decarbonize the power grid. They can't build coal-fired power plants, and they can't stand up another nuclear power plant in the United States without massive resistance. That ties to renewables. Renewables are variable. If the wind doesn't blow or the sun is not shining, power is not generated from those resources. It's a fundamental problem for utilities. How do they provide more power? How do they have a grid that can support it? How do they generate that power, have access to clean power relative to the variability? That's what unfolded in Texas. So I think if I could sum that up, it's migrating from the way utilities have been doing it for the last 100 years to what otherwise looks like the internet. And that's where the investment will come. And it is massive in terms of infrastructure and technology and automation. And we're in the thick of it.
I would think that with both the supply and demand previously with utilities, they had it kind of figured out. People go to their job at 9 in the morning, they come home at 6 and turn on the TV and so forth. Now as people are working from home, they're firing up their computers. It's sunny, so my rooftop solar is helping feed it, but then the cloud goes over and that goes down, and then I plug in my Tesla and start charging it, or there's a power outage and I can actually charge my house off the battery stored in my Tesla, or I've got a power wall. And like when you've got so many different things going on, I guess like what everybody wants is like they want information, and I guess you guys help add that information so at least they get real-time information as to who's turning what on, or whether a house is adding electricity or taking away electricity out of the system. So without that information, they really can't do anything. And so they are in this new electrification world, they need systems like yours.
Yeah, so a few comments on that, Martin. You just described the problem really well. It's complex and it's a mouthful. It is a fundamental shift. It's a paradigm shift, right? From you leave at 9 and you come back from 5 and the utility can plan for it. Well, in COVID-19 world, and potentially a migration to hybrid working environments for a lot of businesses around North America, it's a fundamental change, first and foremost. Then you add the complexity of the EVs and storage walls like you've just referenced. All of a sudden, there's power behind the meter that the utility never anticipated. That changes there every day. And so you'd referenced information. The utility needs information. We provide them with the technology to access that information. The reason why they need the information is ultimately to have control. Not control of what we do each day, but control of the system, the network, the infrastructure that they're responsible for maintaining to deliver electricity to us. If you've lived through a power outage, you know how massively inconvenient it is in today. And I kind of tongue in cheek about my 14-year-old daughter and Wi-Fi. But think about it in today's world. Your communications is shut down because you can't power your iPhone and you don't have a Wi-Fi modem in your home working. Most of our phones are now IP-based. That's gone, right? Additional appliances, smart appliances, those are gone. If we have an electric vehicle and there's no power, you can't charge them. You can't actually drive anywhere. So it's a cascading set of issues. And to that end, there was a wonderful article that the Wall Street Journal 2 weekends ago produced. It was highlighting a study from Princeton University that was talking about the complexity of the electrification of everything. And what the study from Princeton University validated, or based on their data and their assessments, it's anticipated that electric capacity will double in the next 7 to 10 years. Utilities have to double the amount of power that they can deliver, yet they're being constrained on how to actually produce or access. The only way to do that is to not only be much more efficient in how they deliver what they've got, but also to have command and control, most importantly, of how it's being consumed. And like I said, Grid, G-R-I-D, our company, is in the thick of helping utilities prepare for that.
Well, if that's not a good place to end things, I don't know what is. So we're well over an hour here. It's very in-depth, a ton of information. are there any final, I think that was a great closing comment, but any final things you want to say before we wrap it up here, Peter?
First and foremost, thank you for the questions and the inclusion of Tantalus in your webinar series. It's a privilege to be here, and I appreciate everybody's attention and willingness to allocate some time to learn more about our business. This is different than the traditional publicly traded company up in Canada. We're not in the mining space. We're not a cannabis company, although those would be a lot simpler to explain, I think. But we're one of the few companies on the Toronto Stock Exchange today that is in the thick of helping utilities improve their infrastructure and as a result, driving sustainability and improving our environment. So if that's of interest to you, please continue to learn more about our business. And Martin, we're at your disposal for any follow-up questions that may come through your network.
All right. Well, everyone, thank you very much for all joining us today. It was a long and informative, and I thought fascinating discussion about the grid and smart grid and everything that's going on there. So thank you very much. Have a great day, and we'll talk to everyone again soon. Cheers.
Thank you.